So I'm going to give a very quick update on the Mria project, what we've been developing for some months. So what is Mria? It's an extension to the Mnesia database that helps it to scale horizontally. Originally, the project was called RLog, but we decided to change the name and split this project to a separate repo. So what is Mnesia and how does EMQ use it? Mnesia is an embedded distributed database that comes with Erlang distribution. EMQX uses it to store the following data: runtime data about MQTT topics, subscribers and routes, configuration, ACLs, and many more. Mnesia is an ACID database that uses full mesh peer-to-peer model for transaction replication. It uses a variation of two-phase commit to synchronize the transactions. Mnesia uses Erlang distribution protocol for data replication and transaction coordination. So where comes the problems with Mnesia? First of all, full mesh model is susceptible to network partitions. Also, transaction latency tends to grow as the number of nodes in the cluster grows, as shown in the graph. So with different network latency and different cluster size, each transaction takes more and more time because more coordination is needed to take the lock, and more coordination is needed to commit the transaction to all nodes. Also, Erlang distribution protocol is prone to congestion. So how do we address these problems in Mria? First of all, we split the cluster into two kinds of nodes: core nodes and replicant nodes. Core nodes behave very much like regular Mnesia nodes, and they use Mnesia for replication. It is recommended to have several core nodes to have redundancy of the data and improve fault tolerance of the cluster. But the real deal of Mria is the replicant nodes. They don't originate write transactions directly. Instead, they do an RPC to one of the core nodes to do a write transaction for them. Then we use gen RPC transport to replicate the transactions asynchronously from the core nodes. This brings eventual consistency into Mnesia cluster. So we can achieve higher transaction throughput by relaxing the consistency guarantees. Because replicant nodes, they don't hold any logs and they don't participate in the Mnesia two-phase commit protocol. But they can run read-only transaction locally on the local data. So they operate on a consistent, but perhaps a bit outdated snapshot of the data. So what was changed since the last demo? First of all, we split out the project from ICA repo to a separate repo. We renamed it to Mria because we want to share our work with asynchronous. We want to share our work with wider Erlang and Elixir community. We implemented dynamic schema and dynamic shard features, and we did some improvements on the consistency. So name was inspired by the AN255 Mria plane, which used to be the largest cargo plane in the world. So it's a nice name for a database. It ends with IA as Mnesia, and it's short and easy to type. So here's a historical photo of Mria carrying Mnesia transactions. Yeah, so how ICA was split. Auto cluster feature remains in ICA, global logs remains in ICA, and some other features as well. What we moved to Mria is ICA Mnesia and auto heal features. So let's briefly talk about the new features. improved schema management. So this is how one used to declare a table in Mnesia before. There's quite a lot of stuff going on. First of all, there's a notation to assign a table to the shard. We implement some callbacks to create a table or a table copy, and it's a bit boilerplate and also static as well. So after the change, in order to create a table, you just do this, and Mria figures out whether you need to add a table copy or add it to the shard, or maybe restart the shard so it copies the new data. And the user does not need to worry about anything. So it's much easier to declare a table now. It's possible to create tables and shards in the runtime, which is needed to support EMQX gateway feature. And it resolves some theoretical problems with missing tables and whatnot. There's one con to this approach, which is table copies are created on all nodes, whether or not they are needed there or not. So future work, we will write some blog posts and documentation about how we implemented this feature and how the users can use it efficiently. We will repeat our work on integrating Mria to MQX, and there is also one known consistency bug what we need to address. Yeah, that's it. Questions?
No question. Rather, Dmitry, could you quickly show the EIP document that we proposed this solution in your browser?
Sure.
Yes, so this is our proposal document for the whole solution. For people who are interested in knowing more details about this project, you're welcome to have a look and send an issue or ask a question in the discussion tab.
Yeah, also the new repo is here.
Yeah,
the README needs to be updated.
Mm-hmm.
Yeah.
Okay, great. Thanks.